anyone is having any idea about what is OT and how it's different from IT? In chat, can you can just give me some short description that what do you mean by what's your understanding about OT? I just got the only one no. Okay. Yeah. Okay. So when we talk about the OT, if I say it's basically an hardware and software systems that monitors, controls devices, physical devices, and processes and infrastructure. Um, so, what do you mean by this explanation, like this definition that you can hard? This is refer to the hardware and the software that monitor and control the physical devices, process, and infrastructure in industry like manufacturing and energy, and why we need it. Anyone have any thought? Why we need any kind of technology to be introduced in this kind of organization? No. Correct. One point would be the automation, but you just think of it as a technology behind the machines that keeps factories and power plant and transportation systems and water treatment plant facility running safely and efficiently. So when we are saying when I am saying it, okay, when we saying it is OT, and we are managing or controlling the physical devices. So when we are running the huge plant what like let's say the power plants, when we are saying a power plants, we do have transformers over there, we do have some relay systems. So how you will able to, it's a big plant, you are taking some input, like you generating the energy from somewhere by and then that energy is converting into the electricity. So it's a huge process. So how you're going to manage it? With, you can't visit the site and manage the each and every device separately. It's very tough to manage it. So that's why the OT, this technology comes behind that, so that you can manage all the physical devices and control them, and and run the plant in an effective way and in a secure way. Correct. Correct. They smartly handle the industrial process. So yeah, so that's the main objective of to introduce technology for in OT. And when we talk about, okay, let's talk about why, how it's different from IT, and when we are saying the OT. So when IT is basically, when we talk about this information technology, information technology is that dealing with the data, email, or business systems, and OT deals with the real world operations like machines, valves, robots, turbines, and assembly lines, and so on. So that's the major difference. When we are talking about the IT is more about the data, okay, and OT is basically the real world, the how you can operate the operations of those physical devices. So that's the main picture comes when we are talking about why it's necessary to introduce the OT environment. Uh, in a think in a way as well, as like suppose if you're managing this power plant, when you where you're generating the huge amount of electricity source, okay, and then you're distributing that in electricity to the somewhere, like to the house, to the companies. So it's basically a process which, if something goes wrong, it can impact the life as well as, and it will impact the over, the surrounding area. So it's very necessary that we can have a view of all the plants and at some place by using some kind of technology, and then you can able to understand and identify as well as if there is any issue, you can rectify and minimize this kind of problems, because those plants, the person who is working over there, any engineer or any plant supervisor, their life is important. So their life is important means that safety is more the primary concern to introduce the technology in these kind of organizations. And when we are talking about the IT, It's majorly deals with the data. Okay, so the what kind of data we have, how we can protect that, how it's very necessary to protect our personal information, and it could be a business information as well as. But in OT, we are talking about how we can run the complete plant or any manufacturing unit in a secure way and an efficient way so that we can minimize any kind of risk. And let's say why we are saying that why OT important. Any thought why OT important? After having this come from like the definition as I've explained and why it is necessary, can you just give me a 3 points that why OT is important? Correct. Could be a one factor, huge cost and risk involved. Anyone else? Okay. So there, when we say why OT important, we consider it as a three major pillar. One is safety, that ensure the safe operation of critical systems like electricity, grids, medical equipment, or any railway signals. Okay, uh, how you can improve the the efficiency of that, help the automation process by defining deploying the automate process, reduce the downtime, and increase overall productivity and the reliability. Keep essential services running so that you will able to get the benefit of that plant and the operation is not in halt state. So these are the main factor when we are saying that why OT important. Anyone have any doubt? No. Okay. So I have one question to Jagdeep and Mukul and Lakshmikant who has dropped me on message. Like suppose when we are saying let's okay, safety is important, reliability is important. How efficiency is most important factor now? How efficiency is most important? No. So when we're talking about the efficiency, you're running a huge plant. It could be a power plant. It could be your, manufacturing unit. It could be your water refinery plants. If that process we are not able to run it properly, it's a huge loss. And how we consider the loss that if the plant is not running, correct? Correct. So if the plant is not running, there's some issues, and we are not able to identify. It's a huge loss, and we can't hold that operation for a longer time. Like suppose in this kind of organization, when we are talking power plant or manufacturing unit, or even a 1 minute can be a loss in $1 million. Okay, but when we talk about in IT, IT is majorly we are dealing with the data, and if data breach is happening, then there are some consequences, but it's not impacting anyone life over there. Okay, so that's why we have to be we have to understand that why OT is important, why technology is there to support and make that operation running in an efficient way and in a reliable way. And safety is the major concern, or safety is the most important concern for this kind of organization. Whenever you visit this kind of organization, they will give you one safety training, and that's very necessary. They won't tell you. For them, your technical skills is not the second thing. First is safety. You have to make sure that you understand what safety precaution you have to take while visiting this kind of organization. You should have the the safety shoes on. You should have the jacket on. You have goggles should be there. Helmet should be there. So these kind of organization are critical and risky, and we need this kind of technology to make sure we run this plant in a secure way. Okay. Okay. So let's move to. Does anyone have any idea what if I talk about in a CI tried and in how confidentiality, integrity, and availability is important for in comparison of IT and OT. And you have an idea? Okay, does anyone have an idea what exactly the difference between CIA, this terminology, confidentiality, integrity, and availability? Mukul, Rajesh? Okay. Can you please explain? Like you can just let me know what's your understanding on that part in a short word. Because are you there? Okay. Data information is secure, correct. What about the integrity? Correct. And then availability? Okay. So proper access to the resources. No. So let's understand the CI. Why CI is most important when we talk about it. These are the security principles which we have to address, and this kind of organization runs on this kind of CI security principles. That what's important for the organization. When we are talking about IT, the CI requirement and the requirement of this will change in comparison of OT. Can you go back the previous slide? So when we are talking about the confidentiality, no, the CIA tried one. Sushant, hello, Sushant. Yeah, thank you. Yeah, no, yeah, thank you. So when we're talking about the confidentiality, confidentiality is just to make sure that unauthorized people should not have an access. We have to make if I say in a in other way that only authorized people should have an access of the information. Okay, and when we're talking about the integrity is to make sure no one can make or unauthorized changes modification should not be. Information should be accurate and complete. Okay. And when we are talking about availability, availability is to define that the process or that particular application will be available for the user 24 into 7. Okay, we have to achieve the availability that that resource should be available to run the business. When we are talking about the business in IT, that particular information which is critical and important for the organization too, like suppose a website. So that website should be accessible for the user, those who are accessing that website, okay, web page of the company, and they are trying to utilizing that information for their business purpose. So that information should be available all the time. In the same way, in OT, that process in the plant should be running, without any disruption and should be up and running. So that's the main difference between the CIA tried. Okay. Can we move to the next one? So Lakshmikant, authenticity is basically when we are saying how you will make sure that only authorized people will get an access. So how you will do it? That depends on your authentication and authorization. That's the the supportive framework which we use. Triple A. Okay, authentication, authorization, and accounting. That defines that only the authorized people will access. When we are saying the authorized people will have an access based on this framework, based on the three pillars. That each and every user should authenticate. They should be authorized to access this information because we give the permission like read or write. They should only read it. They can modify it. Okay, we do have certain labels in the systems like Manager can access only this information. If any employee will try to access, it will be denied. So based on the need to know basis. So there are some other factor which we need to decide when we are talking about the confidentiality. Clear? Lakshmakant is clear? Yeah. Okay. So when we say Sushant, slideshow. Let me open share my screen 1 minute. Yeah, is my screen visible?
Sir, it is visible.
Yeah. Okay. So okay. So when we talk about the CIA, okay, in IT, confidentiality is the primary we have to be consider that confidentiality should be there first. That's the main objective. That is data secret. That particular data is authorized, accessible to only authorized people. Okay, then the integrity will come. That is that data which we are saying, giving the access, is it accurate and trustworthy? And when we in availability would be the third pillar. Is data accessible whenever it needed? Okay, so when you like suppose in banking website which you we have a service like internet banking services, and that website or internet banking service not available, so it's impacting the banking process and the business as well as that particular internet banking service not available for the user when they need it. That's why the availability comes. Okay. Now let's talk about the confidentiality. Whenever you log in, they ask you like user and password and as well as the some other factor authentication method by sending you a OTP on your mobile. It could be your finger, some others uh, authentication mechanism. So you just put this information over there, and then you will get the page. That's the confidentiality. And then when you have the confidentiality, is there any way we can change the value on your account balance? Is there any way anyone can do that? Like suppose if I have only 1,000 rupees, I want to change it to 1 lakh. No, correct. So that's the main requirement of integrity, that no one should be able to make the changes. They're just authorized for whatever the purpose they need to, and yes, and they can make the changes only for the but which is not impacting the information, malicious information for the organization. Is that clear? If anyone have question, please, because just let me know, because the chatting I won't be yeah, clear. Thanks, Ankur. Thank you. Thanks, Mukul.
Sure, sir.
Okay.
I will let you know if
Yeah.
there is any question.
Sure, sure. So, and now let's talk about the OT. Okay, the primary goal is to keep the physical machinery running safely and continuously. Think of a power plant and manufacturing flow. Okay, how according to you, Mukul and Jagdish, what should be the period? This pillar requirement. Okay, what should be the first? What should be the main objective of a to implement this thing in OT? Is confidentially should be the factor should become the primary principle, or the availability? No. So for OT environment, but surely, so for OT environment, availability is the main pillar or security principle that organization should achieve. That particular process should running without any kind of disruption. Then it comes to integrity. Whatever the command we are sending to the controls or those physical devices to manage it through the technology which we are using to manage it and have a look of those plants, we should not be there should not be a way to manipulate that information or the command which we are sending to the physical device, and which can basically impact the behavior of those physical device and disrupt the whole operation, and as well as it will create the safety issues as well as for the people, those who are working over there. And then the last objective in OT is confidentiality. That is the data secret. So that's how when we talk about the IoT and OT, this security principle will change. What's the main requirement for OT? Availability, then integrity and the confidentiality. But when we talk about the IoT organizations, the confidentiality should be the primary pillar, then integrity, and then availability. Clear? Clear? If anyone have any question, please let me know. Okay. So when we just take, say that just thank you, thanks a lot, Shumikant. So when we talk about the IT and OT, IT is always focused on the data, application, and the business systems. When we talk about the OT, how we are controlling the physical processes, machinery, and the infrastructure. And when we talk about the environment, office settings, data centers, cloud platform, but when OT, industrial plant, factories, power grid, transportation systems. So these are the environments we focus on. IT more focus on the data security, processing, and the connectivity, where in operation technology, safety, reliability, and real-time control is the focus. What are the communication protocol, the standard protocol which we use in IT, like TCP, UDP, HTTPS, SMTP, DNS, and in OT we have Modbus, we have Siemens S7 protocol, we have OPC UA, we have DNP3 protocols. Response time millisecond to second, the latency is tolerable. Okay, and the in OT real time or near real time. Low latency is critical. Okay. So, does anyone have any idea what exactly about when we are talking the latency is tolerable in IT, but it's not tolerable or critical in OT? Why so? Does have anyone have an idea what does it what is the meaning of the latency in the context of IT and OT? No? Correct. So like suppose. Okay. So when we talk about the latency is that how quickly we are sending the information and receiving it. So in IT or when you're browsing your website in like banking website, so it's okay that you are getting the responses in few seconds. Even sometimes it takes more than 50 seconds to get just to have the web page, and then you log in it. It takes some time, few seconds late, then you get in, then you transfer it the amount, uh, you know get into the dashboard, you do your process. That latency is fine. Okay, it's not going to impact. But in OT, if when you're managing the big plant and you're sending some command to change the value of water pump. Suppose you're managing the flow of water, that what should be the flow. You're managing in power plant, what should be your electricity, the power should be, how you have to regulate the power regulatory the power factor over there. Okay, and as well as the water flow, chemical valve should be on, off. You have to change the direction that the complete process. So if you're sending this command from your systems and it's and reaching to the the physical devices and it's more than, I'll say, 50 seconds or 30 seconds, that less latency is not acceptable, because within that duration it can impact the complete process, organization, and as well as the life of the people who those who are working at the plant. So that's why the latency is very critical in OT, but in YT it's very tolerable. We can okay, we can wait, but in OT no, latency there should be very minimum. Okay, clear? Okay. So majorly the lifespan of the IT devices are 3 to 5 years, and after 3 to 5 years, we are changing the hardware, we are upgrading the hardware, we are coming with a different solution. But OT is not possible because those are the very costly machinery which we use in at the plant. So it's very, it's a very tough to change those hardwares at regular 3 or to 5 years in interval span. So we do have 20 years old system at the plant. How we can manage at this stage where those system has hardware has been discontinued by the vendor. So these are the critical aspect which we need to consider in OT as well as. Okay. So when we talk about the security priority, data confidentiality, integrity are the priority. Okay. And in OT, system availability and the safety is important. Risk impact, what could be the risk impact in IT? Data breach, financial loss, reputation damage. But if in OT, if equipment failure, production loss, safety hazard, physical damage. That's why in OT, safety is most important. Uh, when we talk about the updates and patching, the new patches are coming. If any vulnerability has been found at the particular software or hardware, we you might get the notification for your laptop as well as please upgrade your please download this update, uh, install those updates. But it's not possible in OT because they have to stop the complete operation just to do that. And if something goes wrong, it will disrupt the environment. So it's very tough to update the patches uh, to the OT environment due to the downtime risk. But in IT, we can regularly update and apply the patches. We do have some maintenance window. We can do that. We if something goes wrong, we can recover it. It won't impact much. But in OT, we have to completely shut down the plant. Now now the IT, we are seeing it, we are moving the complete data center to the cloud. Even AI has been introduced. In a similar way, OT, we have the IoT SCADA system on cloud as computing, but it's still in the organization they are not very open to put their plant to application or the softwares on the cloud to run the plant. Okay, so the OT environment is learning it to adapt the new technology, and yeah, slowly they will move the certain uh, requirements on the cloud to manage the complete plant. Clear? Please do let me know if something is you are not able to get it. Please do let me know and stop me there. Okay, shall I move? Yeah, thank you. Okay.
Yes,
So
yes,
when
sir.
we thank you. When we talk about the OT component, okay, what are the major or most important OT components we have in a OT environment? So we do have remote terminal unit. We do have program logic controller. We do have SCADA. We do have HMI. We do have some other component as well as like OPC is there. Okay, we do have historian. We have power relay, IO system. So we do have some others, but these are the major, the most important components which we use in OT environment. Okay, when we talk about the remote terminal unit, this is basically a device that monitors and control field equipment and take the input from the physical device and transmit to the SCADA system. Okay, when we talk about the PLC is like a logic controller. Okay, this is a computer, or the software, or you can say the computer which we use to automate the process by monitoring the input, making decision, and controlling output. Like suppose it's basically a if and else condition which we use in a PLC, that if the voltage is going beyond this, we have to shut down that. If it is low, we have to notify or something. So this kind of logic which we put to maintain those machinery, the physical devices, we use PLC, and that PLC is basically connecting to the physical device, and the PLC will send the information, or or the command to the those physical device to manage it. That's why the PLC is most important part. Okay, our most important component. When we talk about the, does anyone have any idea about the SCADA and DCs? Anyone? Okay, Amit, can you just let me know what's the difference between SCADA and DCs? I'll just show you the document once. Anyone? Okay. Anyone? No one is responding. Why? Is my screen visible?
Yes, sir, it is ready.
Yeah. Virender Thakkar has raised their hand. Can you? What's the question? Okay. Thank you. Thanks, Jyoti. So when we talk about the SCADA and the DCs, we do have a DC system as well as. What's the major difference between SCADA and DCs? So SCADA is basically if I just to give you the full form of that SCADA is basically a supervisory control and data acquisition system, and DCS is distributed control system. The functioning of the both systems are same. The only difference, the SCADA is a centralized server or system which can manage multiple sites, multiple plant, and that will give you the single panel view to for all the plants. But when we talk about the DCS, and when we talk about the DC systems, the DC system is specific to that plant and to manage it. It's the local. But it's SCADA is the central system, and it can be help us to monitor and manage the complete or no, all, like suppose more than 5 plants. If you want to monitor on one SCADA system or from one place, and you want to see the how what exactly the plant look like, how your process is running for all the 5 plants, you will go with the SCADA system. But there, and when you have very small plant, and then you will just have only one a plant or site, you will use DC system to have a view how your process is running, how the machines are working, physical devices are working, how, and you can manage it through the DC system. So that's the major difference only. That's one is the centralized, and another is the this local one. Okay, clear? Okay. So as I have explained, the SCADA, the control power, we in OT environment we say as control tower for geographical large areas. So that's a centralized system that monitors and supervise operations spread across the vast distance and designed to for remote monitoring and data collection. So we are monitoring the large plant. We have connected the physical devices through PLCs, RTUs, getting those input, displaying over there on a central system, and that's how we are, defining the what should the decision by through the PLCs. But when we talk about the DCS, a system that directly control complex process within a single site, and it use multiple distributed control for tight, continuous, and highly reliable automation of machinery like boilers, turbines, or chemical mixers. Is this clear? The why? What's the difference between the SCADA and the DCS? Yeah. Anyone have any question? Okay, so I'll just give you that how it works in real environment. So sensors and field device we have, we do have this physical device which monitors, the measure the temperature, flow, pressure, etc. We do have the controllers, the control system, which manage this physical device temperature. We can manage the flows. We can manage the pressure as well as. So PLC and DCS comes there and decide what to do. We have a SCADA system that collects the data from the PLCs, and it will give us the visualization of the complete plant, the processes, and as well as it will notify that the operator, those who are in charge of the plant, that if some kind of uh, malfunction is happening, so it will give the notification, and based on that, operator will take an action on it. So the operator is the person who is basically managing it from the control rooms. Okay, clear? Is clear? Okay. Okay. We do have HMI as well as the most important component is user. That's a user interface that enables interaction between human and machine, which we use in industry automation. Okay, as I have mentioned, there was the difference between PLC and DCS. So we do in PLC we do have discrete operation. Which handles the inputs in binaries like 0 and 1. Now we need to shut down, we need to, allow off and off. So we take the analog input and then convert into digital input, and that's how the PLC will help us to manage those physical devices. And DCS was control the analog as well as digital signal, so it has the capability of both. Response time, this PLC is faster than DCS. DCS is comparatively slower than PLC because it has to, do the lots of process to, for those decision making and then send the command to the physical devices. A PLC is just a simple software which connects with the physical device, and it has only one operation which we can do. We can put certain logic over there if and condition, and like we do in our programming, C programming and C++, we have if this is happening, then you have to take this action. If it's not, then take this. These are the if else conditions. So PLC, when we talk about the scalability, the PLC can only handle a few IOs due to the PLC is used for the small scale equipment, but in DCS is capable to handle several thousands IOs. When we are talking about IOs, it's basically an input-output module. Okay, and that's why the scalability for PLC is very, very at very small scale. But DCS we can have, manage multiple IOs at once. So it's totally based on the requirement of the OT, how big the plant is. So do they need to use PLCs and DCs? So that's how, in that terms we, the PLC, to decide what kind of this kind of solution should we use. So PLC is for the small plant, for small operations if you want to use. But if DCS you want to use the multiple IOs, you want to send the multiple commands to the different operations, and then it will the DCS will come into a picture. Okay. For when we talk about the redundancy, we do have the redundant configuration like master PLCs and slave PLC. In a similar way, we have a DCS like that. The programming logics, we do have the ladder logic. We use functional block diagram. This kind of logic programs we use in PLC. In DCS, we use functional programming majorly to send those commands and program it. So this hardware package comes with HMI, and other software would be required to handle the networking and communication. So HMI is just an interface. Okay, that's the complete package which comes along with the PLC. That HMI will give you the visualization. The PLC in behind will connect, will have the necessary drivers and the other communication protocols of network to connect the physical devices, and that's how the whole process works for the PLCs. And DCS is composed of HMIs and software which would be useful for communication and networking. Okay. Anyone have any question? No. Okay. So this is the the SCADA interface, just for the reference that how SCADA software looks like. Okay. So if you see, so this is the complete the interface which we use. This is basically HMI's interface, human machine interface. That's a package of SCADA system. Okay, you will able to see your multiple plants, the functioning of those operations, the machinery function, how it's working, what's operation, is there any issues or not. You will see the the voltage indication, power indication. You will see all the thing on a single panel view. So that's why this technology is most important for a plant to run in a secure and efficient way. So this is one the software, just for your understanding that what exactly the SCADA system looks like or the interface look like. Okay. Is this clear? Or does anyone want any break? What do you mean by a two-level layer? Yes, yes, you can say that. Yeah. So it's a complete package. Okay, when we talk about the, it's a complete package. The way we use any kind of application, it has a multiple uh, um, sub functions. In the same way, the DCS PLCs will work together to manage your complete operations. Clear? And HMI is just a interface, and which basically we configure it. It's basically how it will give you the exact replication of your how your plant looks and where is, the hardware or any kind of machines are installed. So it will give you, we configure the in OT environment to understand that. What was the question? What was the question? Sorry, because can you tell me the question? 1 minute. Yes, you can address as a PLC as a software, and DCS is as well as a software, which basically have the software, the inbuilt network and communication um, drivers are there to communicate with your physical devices. Is this clear, Rajesh? Yeah, thank you. Anyone have any concern on the SCADA, any of the component which they haven't understand, or they need any kind of clarity on those components? Please let me know so that I can move to the another section. Shall I move? Okay. So Rajesh, I'll just show you that how basically your, the in real time it works. I'll just give you 1 minute. Hope my screen is visible. Rajesh? Yeah, thank you. So like suppose, I'm just giving you as an example of power plant. So like suppose when we talk about the power plant, the core process, what we have, that we do have a fuel or energy. Okay. So we convert for the, to generate some kind of energy like steam to run the turbines. And then the main output is electricity. Correct? These are the the core process for a power plant. Okay. Then for OT, the key component roles will come into a picture for this one, sensors and IOs. So the plant and now, they measure the physical properties like temperature, pressure, and flow, and converting them into a data and executing commands. Okay. So our temperature sensor tells the fuel valve how much to open or close. Then PLC will come, the local brains. These controllers handle the repetitive logic for specific equipment like pump, conveyors, and critical system interlocks. So PLC manage the cold conveyor systems or cooling water pump. Then the DCS systems maintain the boiler pressure at 180 bar by adjusting fuel and water flow. Once so then you will see that information on the HMIs. This is one of the part. Okay, either you are using a DCS or the SCADA. So HMI is the the software combined package which comes. So we do have the HMI is just a dashboard for the operator to have a graphical representation or exactical picture view of the plant, the where those hardware plants are running, how the exactly the valve flow. You will see the how those uh, physical devices are connected. You will be able to see on the HMIs. Okay. And in similar way, the RTUs, the field data messenger, remote terminal unit in substation, collect the electrical data and send it to SCADA um, for the visibility perspective. So this is the complete flow that inside the plant, real-time process controllers. These are the sensors, PLCs, DCS, then HMI, then you have the SCADAs, and then you will able to or through SCADA system, one view of a single panel view where you have the complete picture how the plant is running. You will able to monitor it, you can manage it, and these are the RTOs, which basically, remotely you can connect to those sensors, get those input, process that information to the DCS or the SCADA to make them, or define your decision over there, how to run that plant. Is this clear? Rajesh, is this clear? Hope this is clear. Hello, Rajesh, there? No one have any question? Any special technique, tool to secure PLC DCS system from cyber threat or each? We'll discuss on this. We'll discuss on this. Okay, so Rajesh, so when we talk about the PLC HMIs, it's a combined software. Okay, HMI is just for your graphical, uh, or screen or monitor, which will give you the complete uh, pictorial representation of your plant. Then DCS would be there along with the PLC to manage it. But when we talk about the DLC, DCS will able to manage multiple IOs, more than hundreds of IOs to that IOs are communicating with the physical device to sending your digital input to the analog in an analog fashion in analog signal. So DCS will do that. HMI is just combined package. It will give you the geographical one. PLC is PLC is like a DCS only, but it can only manage or very limited to manage only few IOs. Yeah, but you will able to, yeah, you will able to understand, and you will actually work on those solutions, or you can say this software. But for your understanding, HMI is just the just now I have shown you one a picture of the system is where you will able to see the complete plants, where the water tanks are there, wells are there. So that's basically the interface for operator to view. Okay, and then you will how you will manage those things. So either DCS can be come into the picture, or the PLC have a limitation to manage only few IOs. But if you have a large plant, and when you're managing a number of physical device, then the DCS system will come into that picture. Okay, hope Rajesh this thing is clear for you. Thank you. Yeah, Jagdeep will discuss on this, the what kind of technique tools we can use for to secure the PLCs and others from the cyber threat. Thank you. So, so the most important factor in OT nowadays, it has to be taken into consideration when we talk about the IT. That we have a data center, we have the certain network segmentation, we have access layer switch, we have distribution switch, we have core switch, we have separate DMZ, demilitarized zones where we are keeping our in application which are exposed to our internet. Okay, so we how that's how we segregate the network architecture. In a OT as well as we do have Purdue or you can say Purdue levels, okay, or you can say the Purdue Enterprise Reference Architecture. So that all the network architecture should be lie based on this segmentation. We should place our systems in this way so that all the systems are segmented and have a different communication channel to minimize the attack surface. If suppose it's a flat network that I am connecting every system to one switch, if that switch get exploited by attacker, we are done. So we have to limit, how we can, minimize the attack surfaces by segmentation, by network segmentation. So that's how, we in OT we have a Purdue enterprise reference architecture to follow. But most of the organization OT, they don't follow it. But now, as soon as they are adapting towards the cybersecurity and this kind of threats and how those cyber threats can impact their operations, they are implementing and refining their network architecture as per the Purdue. Okay. So when we talk about the para or Purdue and enterprise reference architecture, level zero. Okay. So level zero is basically a field and IO devices, like all the field devices, sensors are placed on the level zero. We says, that's a level zero for us in the network segmentation. Then we have the control level one, the controllers. Okay, the field controllers. We can say PLC as well as here the controllers when we talk about. Then we have the another level, the HMIs, human and machine interface. Okay, either you can keep a local HMI, that local HMI is sending the traffic to to the another HMI. We can do that. That's how we can segregate. So level two. Then beyond that we have level three. So level two, level 2.5, we do have the this kind of network segmentation OT environment as per the para 2.5. Then 3, 3.5, 4, 4.5, 5. So that's how we have, as if we want to segment, we have to segment the network architecture, how your business, how you can minimize your communication of those OT related traffic to your IT. Okay, it's not like that when you have a plant. Okay, they must, there must be a some their IT business operation is also going on. Okay, how you're connecting the IT infrastructure to OT, that is most critical part. So we the IT to OT convergences. So this kind of network architecture should be there, and we should follow this network segmentation to minimize the security risk. Okay. So when we talk about level 2.5, or here we are seeing as 2 by 3, we have HMIs there, we have application server, we have database server, we have our historian, we have domain controller, engineering workstation from where the engineering managing or view all the these operations, complete process. Domain controller, we don't want to use the same domain controller for authorize the IT system and OT system. So we keep the different domain controller for OT system to authenticate. Okay. For user to authenticate, so we use the different domain controller. We have the historian basically the database. So it keeps the data of the input, the IOs, like the values or data which we are taking from the physical devices, and keeping into historian database for backup purpose and for the as for the regulation as well as. So we have the database server, then HMI, then we have the plant, the level three. There we will come, we'll place our antivirus, your Windows service, update services, patch server, which we say, we also call it as a patch server, as WSS. We have historian. So this is your primary historian. This is your parent one. Then you have remote access jump server. Remote access jump servers are basically the server when someone is trying to connect, they will connect to remote server, and from their remote server, you will have an access to these devices or this level. Then we have the level 4, that which we call enterprise zone, where your business people, they connect, they work. Okay, your IT level processes are going on. So level 4, the domain controllers, web server with their business servers are there, ERM softwares. Okay, so enterprise desktops, and then enterprise the level 5. If you have the public websites which you have hosted for the user purpose and the email servers. So that's how we have the Purdue architecture is most critical, that we have to follow a segment the network of OT and the uh, um, of OT um, as compared to IT, how we can minimize the attack surfaces. Is this clear? Does anyone have any question on it? Any question? It would be great if it is interactive session. It will be helpful for you only. Yeah. So as Jagdish, you have mentioned it that how what kind of software system and software we use to protect the DCS systems or these OT softwares against the cyber threat. So this is the primary and most important step which we need to take, the network segmentation. If we don't have a proper network segmentation, it means we are keeping our attack surface wide open. If one of the system gets exploited by certain vulnerabilities, it can, exploit the other systems. But if we have a proper network segmentation. If that particular system, suppose your level 4 system is exploited by attacker, but we do have a protection here. We do have a firewall. We have a segmentation. We are not allowing every traffic here. So we are protecting the below down level architecture. So that's why, it's not like that we are placing a software, like suppose I'm placing a firewall, IPS, we are monitoring some SIM tool, and that's then only we can protect. No, the main feature or like main requirement is how we are minimizing the secure attack surface, and how you can do it by defining a network segmentation, a proper network segmentation between these components that are, the network components, the processes has to be there. Otherwise, it's gonna you will open the wide open attack surface for attacker to exploit it and disturb the services and operations. Clear, Jagdish? Any question, Vikas, from anyone in chat? Hello.
Not till now, sir. No,
Okay.
not till now.
Okay. Thank you. Does anyone know, want a 5 minutes break for water to refresh themselves or coffee? Yeah, sure. So what's the time right now? It's 7:10. We'll be back by 7:18. 8 minutes break. Is it enough? Eh, Yeah. Okay. Thanks, Amit. Because I'm just switching off my camera and we'll be back in 8 minutes. Okay.
Sir, sir.
Thank you, Kash.